Marcel's in the.
There. All right, back from the break. So we've got one session before them anyway. So the next one is the opportunistic whole object checksums for the OSD, and I guess this one was you too, Sage. So if you want to take her away.
Yep. Yeah. Hopefully, Sam will finish up his chicken tikka masala here shortly. So the basic idea here is that ideally, we want to have checksums of the data we're storing on disk. We don't do it in general because it would be very expensive to maintain it as far as the recalculating checksums and maintaining them on a fine enough granularity and then updating them and dealing with partial block overwrites and all that stuff. And because we are always assuming that people would be running Btrfs, and Btrfs is already doing this underneath the covers, so we just haven't done it. There is a simple checksumming mechanism in there that does it on sort of a block basis, where blocks are like 64K or something. They store them in X-adders, and it's opportunistic in that it only updates them and verifies them if you happen to read or overwrite a complete block. And if you do a partial block, it'll just invalidate it. So that's already implemented. I mean, we use it in QA only. It's unclear whether it's going to perform or be a good idea to do in a production cluster. This blueprint is sort of coming at it from a different angle. The basic idea being that in any given storage cluster, there's some portion of the data that's being actively modified, but they're usually objects that are written and then they just sit there and don't get touched. On the other hand, we are doing background scrubbing every couple of weeks where we will calculate the full checksum or recalculate it and then verify that the on-disk bytes are okay. So the basic idea is that when we do that scrub, we just make a record of the full object checksum. And so that later, if a year down the line, your disk grows a bad sector, you'll actually know what it used to be or what it should be, and you'll be able to compare. You'll be able to tell which replica is broken. So in a replicated pool, if you detect inconsistency between the copies of the object, it's not clear which one is the right one. You can, if it's 3 replicas, then you can assume or guess that if one of them is different than the other 2, then the 2 are correct and the 1 is wrong. That's usually a decent strategy. But this actually storing a checksum would mean that you would know just by virtue, without even comparing to the replicas, that it was incorrect. And you could trigger a repair. So, right. So the basic idea here is to expand, add a couple of extra fields to the object info T, which is the sort of the per object metadata structure that we already have. That includes a checksum. On scrub, we would compare with the checksum that we expected to have, and if it's different, then we would trigger an error. And if we don't have a stored checksum and the scrub is successful, then we would just record it basically, so that for next time we would know what it is. That means that a scrub, which is normally a read-only operation, will generate a bunch of write I/O. But the hope is that usually an object goes from hot to cold once or infrequently, and so it would in the aggregate be like 1 I/O per object in the cluster, or per cold object in the cluster, usually. And we could also add a few simple heuristics that would just maybe skip recording the object if it's just been changed and wait for the next scrub before we do it. Maybe not. So that's the basic idea. Hold on just a sec. Let's see if. I guess the real question is whether we want to implement this. Well, A, whether there are improvements that we can make to this basic idea, and B, whether we actually want to do this during the Hammer timeframe. So don't know. Are there strong opinions one way or the other?
If only from the perspective of being able to figure out which of your replicas is actually correct, it seems like a really cool idea to me. It ties into that sort of diagnosability, repairability thing that I had a CDS or two ago.
Mm-hmm. And that is, the diagnosability thing is sort of a general theme also for Hammer. One of the things I didn't mention earlier is that David is continuing to work on the back end object store tool and on scrub and repair to make it more robust and more friendly to use and all that stuff. So it's topical, certainly. Okay, well, I guess so. There are some specific concerns or issues, I guess. So there's the general idea is that you write the object, and then at some point later, then you will scrub the object. And so there's a gap where you could have the object could have been modified or corrupted in flight or something before you say, oh, I scrubbed it and it's this. So I think that the assumption would be that you would only record the scrubs checksum if it actually matched all the replicas, which makes it a pretty small risk. But I guess the question is it a concern that you could potentially have, a flipped bit while the object was in flight being written, or, miraculously all copies of the object corrupted in the same way? Or, maybe you only have, well, you only scrub when you have all replicas clean, so I guess you don't have to worry about the third case. But does that concern anybody? Or is this still leaps and bounds better than the alternative?
Even if it does concern people, it's still better than the alternative.
Yeah, you're muted, Greg, by the way.
Yeah, that was me telling Sam he was muted.
Okay.
Yeah, right. Sounds better than than not having any checksums. I wonder if there's something. I haven't done any research in this area, but I wonder if there's something clever we can do in terms of yeah, no, never mind. I have no idea. It'd be nice if there was some kind of checksum that we could apply that we could modify on writes, but of course, no one has that.
I mean, I think the way that Butterfest does this is it just stores a CRC per 4K block in a B tree.
Well, yeah, and it knows, and that's a hard disk problem anyway, so it can deal with that it's only reading and writing in those sizes. But
yeah,
you don't really want to have to do those reads into our memory space. Yeah.
Yep. Yep.
Anyway, I mean, I think that we're pretty safe if we're doing a scrub and then everyone agrees on the values and then we write those values, then that means that it was already corrupted everywhere, and so we're never going to be able to fix it anyway. And we would never have noticed on our own that it was bad.
So it's much better than nothing at all, so we should do something. This proposal is to have a single CRC for the entire object, which we happen to have when we do a scrub. But we could alternatively make a big chunk, 128 Ka or a megabyte or something like that, and also store them on those granularities. And so that if you happen to do a 4K overwrite, you only invalidate part of the CRC. Does that seem worthwhile, or is it?
It seems to me that if you do it at object granularity, then you only invalidate the object you're writing to, which is kind of the same thing, but several orders of magnitude bigger and easy.
Right.
And we don't store as much metadata.
Yeah.
In other words, I don't think there's a qualitative difference. I think it's just a difference in chunk size.
Right. Yeah. So, but specifically, when we go to implement this, should we just do a whole object, or do you think it's worth doing?
I think the difference in complexity of implementation between whole object and little pieces of object is much bigger than the gain.
Absolutely.
Yeah. Yeah. Who was that?
That
was Paul.
Even if you do the 128K chunk, you're still writing to the object string scrubs. So I don't see much of a difference.
Yeah.
Incidentally, you only have to write to the objects that have been written since the last scrub.
Right.
Yeah.
So if you
So-
genuinely have cold objects, then they won't be written on each scrub.
Yep. So this is 1 IO per transition to being cold, basically.
Would there be any value in the cases where we can determine that we know we're writing the whole object to also update on write? I mean, I guess
Yeah.
I'm talking about things like RBD.
Well,
Or the
RBD
object
hardly
doesn't
ever
know.
writes a full 4 megabyte object. That doesn't really happen.
Mhm.
Anytime we see a write full, we could choose to include the checksum.
Mhm.
Well, and that's already an existing option, right?
No.
Well, we don't store the checksums at all, so no, not yet.
Oh.
but that's we'll have a session of that in 45 minutes. So,
Okay. I thought you had the opportunistic thing already for debugging.
That's a different thing.
oh yeah.
Yeah,
Oh, it's a
Well,
different
so-
Rados. It's a different Rados op to write the whole object, so you can tell easily.
Sort of, yes. Yeah. It's not always marked that way, but either way, you could just detect that the write happens to span the entire object also, and do it then. So it's not too hard.
Or on create. So even if there's a partial write, but it's creating the object from nothing, then you could store the CRC.
Yeah. Exactly. Yep. And if it's an append, you can chain the CRC on too. Like there are a bunch of cases where we can sort of special case, because the CRC, the way that it works, whatever you can. If you're appending to a buffer, you can efficiently sort of adjust the CRC to include the new data based on that. Okay. So did I capture all those? Let's see, limited scrum. So let's see, other optimizations we can do. Object writes, pens, possibly.
Are you writing in the pad, Sage?
Yes. Oh, I'm in the wrong.
Yeah.
The wrong one.
Yeah, so I hadn't seen any notes show up in the whole object checksum pad.
Opportunistic. There it goes. That's why. So for hammer, should we do this for this cycle? Bam.
I don't know. So we're trying to get the queue thing in. We're trying to get being able to write to degraded objects in, and we're trying to get active but or readable below min size in. So I think the question is, where does it fall with relation to those?
Yeah.
And I think
Well,
it's less important for those.
Yeah, it's also not doesn't interfere with any of that code too. So
That's true.
Independent person. And I think it does fit nicely with the if David, for example, is going to be working on the scrub repair stuff some more, then it fits nicely into scrub and repair.
Yep.
So I have a question. Is there times, I know we have a scheduled deep scrub, but are there times when a deep scrub is done automatically? For example, if we lose a node or something like that?
Scrub is not used for repair. We have a more efficient way to do that.
Okay.
Yeah.
It does, however,
and
happen
also-
periodically, automatically. But yeah.
Yeah.
I know that.
Notably, it only happens when the PG is clean. So if you have only 2 replicas instead of 3 replicas, then we won't scrub it. We'll wait until you have all of them.
That makes sense.
Yep. Okay. Let's see. Are there other pieces? I had another thought a minute ago. Okay. So we can jump ahead a minute, actually. If you look at the pad I'll paste it in, for the Liberatus one. One of the questions is whether we should be generalizing our representation of a checksum. Right now, we're just using CRC32 everywhere and sort of assuming that. Is it worth introducing a generic type to capture that checksum so that we can swap it out later or have multiple checksums?
Well, they can't be easily changed anyway for compatibility reasons. So we'd have to build an actual framework in to like identify which checksum it was. That seems like a lot of work.
Right. So the idea would be to, before we add another field that's typed CRC32C, we would instead use a new structure that encapsulates a checksum with a type field and a sort of variable length payload.
No,
Right,
I
so
know, but the sort of difference between that and just doing that later when we have a second CRC to add doesn't seem big.
That depends how many places they're embedded and need to be compared between.
Where they're encoded.
Yeah, I would argue that we're not going to get a lot of commonality there anyway. The way checksums are used, it varies between use, and there will be different behavior if the checksums are different types, or what that would even mean, or how that could even happen. I'm not sure there's a lot to generalize.
Well, I mean, right now, the way you'd have to do it is have the replicated PG code or whatever just do an equality check on the CRC32, right?
No, I know. And what it would do is it would just choose to ignore it if it didn't match. And that's all we're talking about here.
Right, but I mean, if you abstract it out, then you can say, do a comparison.
I know.
Like on the functions, and then if you add a new one, it's just that one struct you need to change, rather than the other ones. Like all the callers. I don't know.
Yes. But the hard part is that all of the users have to be aware of what to do if they're comparing checksums that, for whatever reason, are different kinds of checksum. That's the weird part. We can't generalize that. I'm not sure there's much here. I mean, I'm all for adding the struct, but I don't think that it actually saves us much work either way.
Well, in the case of a scrub, also we'd have to, the PG at scrub time, you'd have to decide, you have to tell everyone who's scrubbing, use this CRC, right?
Yeah,
so that you actually can compare the results.
And that also cannot be generalized. It will be different for every CRC use. There really isn't that much commonality.
You mean because of the sort of unique properties of the checksum itself?
No, I just mean we use checksums for different things. And the interesting thing isn't the checksum here. It could be any checksum. The interesting thing is that we're using it to make a statement about whether the contents of the object of different PGs happen to be the same. With the opportunistic one on disk, we're checking whether it was the same as what it was written. It's all the same kind of thing, but here it's that part where we send the message indicating which one we should use. That's the challenging piece, not the details of how it was written down in the adder or wherever we choose to put it.
Wonder if we should think twice before we put yet another CRC32 field.
Well,
it's going to make it that much harder later.
It's fine if it's a CRC32 field, but we're probably going to stick it. Well, do you think we put it in the object info or in a separate attribute? I guess we put it in the object info. Okay.
Yeah.
I mean, you could wrap it in a struct. That way we can change the encoding later, but meh.
Yeah. Okay.
Because all we really need is a version struct for it instead.
Yeah, actually, that would be since we only have one type, then you can skip all the rest of it until later. Okay.
Also, I mean, everything supports CRC, right? And there's no possibility we'll ever want a cryptographic hash. That wouldn't make any sense. CRC isn't obviously deficient.
Well,
It's not strong, but it protects against random bit flips, which is what we care about here.
Yeah. Yep.
It's pretty weak on a 4 megabyte sized object, though, isn't it?
For cryptographic purposes, it's like nothing. It's not valuable. But for our purposes, where we care about, for example, the object being zeroed.
Well, no, but I mean, the minimum distance separable is not very far, I think. I could be misremembering this, but...
Nah. It's fast to compute, and it will usually detect bit flips. So.
Yeah.
It is weak, but again, it's working with the triple replication.
Yeah. Yep. Oh, I had another question. Sam, on the so on the restricted pools, we already have CRCs stored in the object info. Are they? Is it for the full object, or is it for the? Is it a vector for and a value for each stripe?
Full object, because I was lazy.
Okay.
Oh, I remember. Originally it was going to be, yeah, okay. So originally I had a kind of a packetized format where each stripe had its own little checksum, so that as you did the individual stripe reads, you could do verification. But literally no one else besides me liked that, mostly because it messed up the sort of mapping from stripe size to disk chunk. We were at the place talking to the people. So now it's a whole object checksum, which you update as you append.
Okay.
Did you see the Google code link from the IRC channel?
Double X hash is 11 times faster than CRC32.
Yes, but is that
stronger?
is that including the part where you have specialized hardware already on the CPU that's installed in your hardware to do the CRC32 even faster than that? Or is this 11 times faster than just a naive CPU implementation?
That's a good question.
Yeah.
On my laptop, the accelerated CRC32 stuff was getting about a gig per second. But that's probably more based on like memory bandwidth. The rest of it. What's Q-score? A measure of quality. So it's only slightly better than CRC32. But it's not cryptographic.
Well, I suspect that a measure of quality in which CRC32 is 9 and SHA-1 is 10 is probably pretty generous.
Yeah.
Oh, yeah.
I mean, it could be interesting. If we want to add the field, it's fine. I'm just saying it won't really make it any easier later, really.
Yeah. Yeah.
I'm mostly just leery of things that require changing encodings elsewhere after having gone through much pain to put it everywhere.
We don't have to change the encoding anywhere else. We just leave them as it is. This just means that any further places we put it will be protected.
Right, exactly. I like how there's a... Oh, those are other versions. So there's a C version already. Okay. Got it. Okay. Interesting. Okay.
We got about 5 minutes left in this session. If there's other questions or points people wanted to bring up.
I don't think so. It seems fine to me. Oh, you know what? I wonder if... I guess it doesn't matter. The OSD op, when you actually record the checksum, is just going to appear in the PG log as an update. Currently, I have no distinction between of what the actual update is. In this case, it's metadata only. We haven't actually touched any of the bits, but if you have to recover after that, you have to actually copy the entire object. I mean, yeah. Another can of worms, or if we want to get smart about that, then there's going to be a lot of.
It only applies to repair. It's going to be such small percentage of the objects. I don't care.
And it's only when it's clean, so the probability that we'll have a pretty low. Yeah. Okay. Okay.
So if you're putting those down as normal ops, does that mean that it's actually taking that it's actually a sub-op that the primary is sending around,
Yeah, it'll have to be
which
a rep
which will contain the CRC32s and stuff.
It's going to contain
just
a generic transaction.
Yeah, so it'll just be an updated object info D basically.
Okay.
Static.
So in that case, we actually are relying on that transmission not breaking. So it's flip-on transmission there.
Yes, but that's true literally regardless of what you do, right?
Yeah. For any
I
update
thought,
ever.
in fact, I thought we did CRC32s on messages.
We do.
Well, there you go.
No, that's true. We were talking earlier about computing them, and I was like, oh, well, it's easy because we know that we sent it and it matched it, and the one we got back matches, and the one we already stored and everything, and we aren't actually getting into those checks, but that's okay.
And actually, that means when you're... No, it doesn't matter. Never mind.
Well, I mean, if you find that you go scrub again later, and every copy of the object matches, but they all disagree with the CRC, then the administrator gets to decide whether they just say it's okay or not.
Actually, in that case, I think you warn at the central log and just fix it. There's no point in keeping the old checksum at that point.
Yeah.
If that's the case, I buy a lotto.
Huh?
If that's the case, I buy a lottery ticket because the chances of that happening are really, really slim.
Yeah.
No, an error in the right in the right a memory error at the right point in the computation on the primary would definitely do it.
Okay, I see you.
I'd agree with you if they were all independently calculating it and then writing it out, but they're not.
Mm-hmm.
At least not with this design.
Yeah, that'd be a bit harder to accomplish. Well, I think if you wanted them to do it independently, then we'd probably push it down a layer and do it in the file store.
File store, yeah. It would hook into the opportunistic checksumming or something.
Which, yeah.
I actually prefer this design, the one where it's done at the OSD level.
Mm-hmm.
You should be using ECC memory if you care about your data anyway.
Yeah. Okay. Cool.
All right, does that about wrap that one up?
I think so.